Okay, good morning everybody, good afternoon, depending on where you're calling in from today. I wanted to start the session just to introduce myself to you via webcam, and then after that we'll proceed with the presentation. So thank you again for coming to the presentation that we have planned through Industry Days. And we're really excited to be part of the Industry Days program, and today I'm going to be talking about the future utilization and optimization of materials and properties selection in design process. It's a big topic, but I hope today we'll cover many aspects which are interesting to all of you here today. And from now on, we'll get started. So I'm going to just close down the webcam to ensure that we get the right connection. But once again, thank you to everybody who's joined us so far, and I hope that we'll have an interesting session. It's a tight session. We have 30 minutes today, so there's plenty of information to get in. All right, so let's begin with the content. Now, I think we have most of the people with us in the meeting now. So, as I said, we're really privileged to be here and to introduce our first offering as part of the Industry Days setup. We had so far an excellent response to the presentation in terms of the attendance. So hopefully now we can cover some important topics which will, sorry, just to fix my settings. So now we can hopefully go to the presentation, and we'll just cover off now the agenda and actually a bunch of points that I want to really touch upon during the presentation today. We'll talk about importance of materials information generally, standard materials data, so the relationship between the internal business, the usage of data inside the business, and how that connects to a truly diverse scope of materials information that's available worldwide. We'll get a little bit more personal, I would say, with the topic of internal materials management. And of course, part of the program today is to talk about material selection possibilities. How does that come together? How do we combine external sources of materials information, materials data, with internal intellectual property, whether it's test data, etc., and then deliver that information to the business in a way that's understood and in a way that benefits different profiles of engineers within the business itself. And of course, we'll talk about future technologies and trends and how that relates to the topic of today. So some themes just to start us off. Let's not forget the purpose. Great products are really made with great materials, and that comes from good selection decisions, from validated materials, sourced materials information. But there's a tremendous power that comes from the access to organized, comprehensive data, and we'll talk about that. We'll cover that off in the meeting today, in the discussion today. Also being able to enable and empower users to make right quality, consistent decisions about material selection from a safe and controlled environment. And that sounds interesting because there's a conflict there. As end users of data, we want freedom, but as a business, we also want to exact some control and allow us to tailor the experience of end users to find the information that's useful for them. And digitize and standardize data, which means also the structure of information is important for the flexibility and inclusion in the business information flow in general. That means integration of data, but there has to be a standardized platform and a standardized structure of data to drive that. And of course, exploiting that data in different areas of the business in a way that is compatible with the goals and objectives of the business for innovation, for example. So let's move on. Let's talk about two parts to the jigsaw. So we've got two sections here we're going to talk about. One is about managing standard approved materials data. So there is a huge resource that's required typically to put together information which is going to then improve the decision-making process in the business. And that's related to finding reliable external sources of data, reference data, databases, and the ways in which you're handling that now, I'm sure you will recognize. So whether it's the books on the shelves, going to a database like Total Materia or another organized database which provides this external source of information, or whether it's Google itself, you're recognizing the ways in which you're getting that external source. It's still necessary. So this is this side about how do we bring this reliable external source of data into our everyday lives as a business and then combine it with the other part, and that's about managing internal materials data. So developing a system which controls, protects the intellectual property of your business and drives quality material selection decisions and consistent material selection decisions through the different areas of the business. And of course, in between, there are different points to discuss. How are we able to merge those two worlds? How do we have an external resource and use that to strengthen the internal resource of materials information? These are the basic foundation questions we'll be asking. How do we make a connection between our internal materials and the real-life global complexity of materials? For example, how do we make a material selection decision in one country and then influence an international supply chain to ensure that the decisions about material selection are consistently rolled out to other countries and other localized facilities in the business? That's an important and difficult question to answer. And sharing test data, design values. So when we think about design, simulation, we have a clear understanding of the scope. We want to have the data, whether it's internally produced or whether it's externally sourced, data needs to be validated and ready for simulation users whenever they need it. So putting that together, once we have this platform and this considered combination of external data and internal materials data, we need to then think about connectivity. How do we then maximize the usage of this data in different tools throughout the business? It's not just about a CAE software, it's about PLM, it's about ERP, it's about CAD tools, it's about compliance tools. There are many, many different possibilities for using that data, and having that structured in a reasonable way gives that potential. So we're talking about a library of materials, reference information that can be connected then to internal materials data systems. And you'll know some of these names that are down at the bottom here. We have situation where Total Materia providing a data management tool integrator, and you will also probably know something about Granta, MSC, Tixma, but this is what we're talking about when we think about materials management systems. So again, theoretical point, let's take a step back. So why is standard grade materials important? Well, the fact is that inside the business, although we may be approving those materials, maybe we'll be calling those materials something else, we'll be designating those materials with an internal designation system, they are still connected to standard grade materials. That means materials from ASTM, from IS in India, from GB in China, EN in Europe, DIN in Germany. The fact is that this scope of standardized grade materials is critically important as a bedrock or a foundation for the development of internal approved material lists. So whether it's about making or finished products, or whether it's about manufacturing processes, the reference in most industry sectors is connected to the world of standardized materials. And that's really tough to comprehend, especially when we start thinking about global business. Second thing is to think not only about what type of materials and what type of materials information is important, but also what roles use data for, and also what's important to those specific roles in the business. There isn't just one group. It's not just simulation, I'm sorry to say. I think probably a lot of you are from simulation or CAE. Dare I say, it's not just about you. We also have many other groups in the business which can utilize well-structured data for their jobs, for the things, the roles, the tasks that they're doing, which means that a practical platform for materials information can be used by practically all areas of the business that need data to do their jobs. Whether it's about the materials specialist who has pretty much big responsibility for controlling specs, starting test plans for new material validation. Yes, we have other groups which are monitoring legislation in standardization. Some profiles would be known as product stewards, for example, material stewards. So they have a deep understanding of the standardization of the information coming into the business. We also have, of course, what we would consider more focused data users who, for example, in the case of simulation and CAD, are looking for very specific materials properties in the most part to carry out their business function. So to find advanced properties, stress strain curves, fatigue data in order to run accurate calculations is a simulation specialist's focus. Now, there are many other things that could be interesting. For example, how do we compare material behavior? How do we make a material selection, uncover opportunities to find other possible materials that can do the job in a better, safer, stronger, lighter way. But at the end of the day, the requirements in that area are quite specific, and we'll talk about that as we go through. Quality in purchasing we should not ignore as well, because this group have to be able to relate, like I've told you before, the materials information, the approved material list within a business, and be able to then understand if there are quality issues, if they have to do non-conformity investigations on the materials, how can we improve the process in order to purchase and find suppliers which can provide the right materials to do the job right first time. And purchasing have a whole new challenge when it comes to sourcing local materials, and there's a lot of pressure on those guys to save money. So that combination of tasks, of course, must not jeopardize the integrity of the engineering decisions. So change request between purchasing and the engineering teams is also a critical step. What's the point here? Really, the main takeaway from this slide is that different groups in the business have different roles. They have different jobs. They have different objectives. But using a comprehensive, joined up set of information to make those decisions means that we still have consistency. We have a single source of information for a business, and with a practical approach, it can be accessible by all of these characters in order to drive the main focus of the business, to have good sales and to have a quality supply chain that's coming through from the other end. So it's very, very important that we consider this. So let's run through a couple of points about what's important for reliable data when we think about external materials databases. I'm talking now about total material style or type of reference databases which provide information for the business which is not inside that intellectual property that you hold in the business. The other question, of course, is whether that materials information that you have is in any way organized in such a way that is exploitable, discoverable by different groups in the business. So external databases like Total Material, where people come, it needs to be complete, because more options means more opportunities in material selection. If you don't have the full picture, how can you make informed decisions about materials? The diversity of the data. I already talked about different profiles. If you take a material expert, he's not just thinking about basic durability properties of a material. He's thinking about the application of the material. What happens if we put this into a corrosive environment? What happens if this finished product is left out in the sunlight? What if it's in a situation or an application which is going to have a requirement for welding. What does that do to the integrity of the product? So diversity in the data is critically important. Reliability, accuracy, trustworthy for repeatable results. That means that if you have a reliable resource of data, you're able to ensure that the decisions made upon that data are accurate, but also to ensure that different groups or levels of experience and knowledge in your business are leveled in a way where decisions about materials and information coming from materials can be made consistent. That means that there is a best practice for everybody to go to one place and find the same data and make the same decisions. Curated. What does curated mean? It means looked after. It means kept up to date. It means basically how do you have a resource of information which can be put into place, looked after, and that means that the continuous prospect of obsolescence, which often comes with sources of information like external databases of data, is avoided. But that takes a huge amount of work. I'll talk about that when I talk a little bit about the context of total material. Comparable. That's a simple word, but actually there's a lot of detail and there's a big importance for the knock-on effect of future applications. A relational structure of material information is critical in the optimization of selection possibilities, because if it's not done in an organized and relational way, how can you compare apples with apples? It needs to be done in a way which is organized and delivered to end users where they can easily compare not just similar materials, but also materials from different groups. How do I compare a stainless steel against an aluminium against a composite material in a lightweighting study? This is really important. And it has to be accessible. So if we're talking about global business, it's not just about efficiency and user experience, but it's also about localization. It's also about being able to make this available to different people in the business. So I'm going to be a little bit quicker, but when I talk about material specialists, just to dive in, building specs based on data, I talked about how a material specialist needs to have diversity in the data. That means extended needs of the information, whether it's basic chemical composition, microstructure, different corrosion diagrams, or just basic physical properties. The extended needs need to go through to the business. We see material specialists as providing to internal customers like simulation in a specific way. Simulation specialists, another specific requirement for data. You have different periods or different stages of your analysis work that you're doing. The initiation phase where you're just defining the task, execution of the model, execution of the calculation. And this is where the feeling of not having data starts to appear. You start to get a feeling that you're aware that you need accurate data to do your analysis. You do the analysis, you have to interpret the results. Do you need to do a repeat or an iteration of the calculation? And finally, reporting. That means having to justify the reliability of the discussion. So overall, we're looking for a very decent error margin in our simulation. But how does that relate to the world of materials properties? Well, it's all over the place. Let me be clear. When we look at a very simple use case, I'm going to just focus on this first one. If we take a stainless steel and we look at two different delivery conditions for that stainless steel, you can see a huge difference in the yield stress data according to the delivery condition parameters. We have an annealed material which delivers a yield stress of 345 megapascals, and we have a cold drawn over 1300 megapascals. That's massive. So if we make the wrong decision in the selection of that data, what's that going to do to our simulation error margin? We need to take care. So that's why accurate delivery of materials information from standardized sources is critically important. And it's also about selection. How do we make decisions conceptually about groups of materials? How do we visually make quality decisions based on the selection of properties of interest, maybe about ratios of properties, For example, for light weighting, we can put strength parameters and ratio them with density, defining limits of durability typically to understand minimum levels of strength so we can make quality decisions about materials and also compare these graphically on the material level. And comparing either on the material level or also on the property level, let's say atomic level, being able to take stress-strain curves, compare the deformation behavior of different materials. Here you see an aluminium versus a stainless steel versus a composite. Being able to look at visual relationships between different properties and compare materials side by side to make sound decisions about the material selection going forward. So this idea about materials comparison, material selection has to be done in the context of a sound relational database which is structured to allow that kind of data visualization and comparison. So I have to drop in about how we tackle this problem because it's important. We've been doing what we do for 20 years now, and the Total Materia database offers that comprehensive go-to place for materials information, whether it's about metallic materials, non-metallic materials. For the design simulation group, we have a huge reference and library of experimental data coming from around 3,000 experimental sources. So we are sourcing that information, which means that your typical way to find that data, hunting for the experiment, going to Google, making the assumption that anything is better than nothing, we can help there. And so this is really important for today's takeaways. Data plus Enviro, I talked about material specialists and having access to a wider scope of information and even covering the global compliance and regulations scope and landscape, which is becoming critically important for materials and substances used in the business. So this is all coming together through this comprehensive delivery of materials information. So that's about external resource, that's about standardized data, that's about comprehensive library of information to help make sound decisions based on a huge wealth of information out there. And it's to help you in avoiding, let's say, the regular and common ways in which you will find information currently. You have standards, you have some books, maybe you have some access to some specific websites, you're using some of your information, but more often than not, you're using Google. So to avoid the obvious issues that come with this approach for finding materials information, it's critical to go somewhere that provides that reliable access to comprehensive resource. And that's really what Total Materia or this external materials information is doing. But what we're talking about as well today is how do we combine the internal part with that external part? So it's about combining these two worlds. How can that be done in a practical way? Same approach, few key words about what's important for organizing internal materials management. It needs to be controlled. Do you have a validation process or do you need a validation process for the update of materials and the addition of new materials? It should be traceable. If we make changes to the material, do we need to keep versions of that material? Do we need to track the material changes? Who did what and when? Structure, as I said, critically important. The data structure should be also according to user needs. How do your users search for materials inside the business? This structure dictates this, but flexibility in that structure is important. Accessible, again, efficient, tailored access for different profiles. In a business where control is important, we want to make the experience and the access to data in a tailored way. That means a simulation specialist might just need to get hold of 2, 3, 4, 5 different properties. We need to guide those users to the right properties that have been validated, checked, and released for the business. And that's in a nutshell what these 4 or 5 points talk about. It needs to be up to date. The information needs to be up to date, providing the gold standard for the business of information. One truth, as they say. and it should be integrated, connected to other critical engineering systems in the business. So a few screenshots just to show again how we take on this topic, how we take on this challenge. Being able to create your own material groups in what we call integrator, but it's effectively a data management module, copying materials from total materia database to the data management solution, which provides the foundation of those standardized grades that I was talking about at the start of the presentation, being able to create your own maintenance or user-defined properties, and being able to create a connection between internally approved material lists and the outside world, other standardized materials. So we can tell our colleagues in China, this is the equivalent Chinese GB material you must use to get the best possible results. So this is about moving this to the global level. And now we should talk a little bit about export. I'll be a little bit quicker because we don't have too many minutes left, but I probably will end up running a few minutes over, so I hope you will stay with me. What are the general objectives for export? So we have our two systems in place. We have our internal data combined with our external source of data, and now we need to utilize that data throughout the business. So providing efficient access to the properties used by different end user groups. That's one key point. A CAE specialist has a different requirement to a CAD user. Reducing errors in materials and property selection. Delivering properties in formats that fit the existing workflow of the data users, and simple but practical approaches in limiting the IT development required by the client. That's important because if we make something too complex, it's not going to work for us as a business. It needs to be done in a way that fits to the requirement of the business. So how do we think about export options? Well, we think flexibly and we think tailored. Property by property is possible, so exporting property by property of the selection of the end user. Creating a one-click approach, which means being able to select all of the properties defined for a specific export format. Bulk exporting, which is typically normally used to update mass periodic population of other repositories, maybe inside a CAD or CAE system or PLM system or ERP system. Bulk exporting data and moving data around is important. Lighter integration options from other softwares, and also API. API is normally a hot topic when discussing connectivity, but it's not for every company, it's not for every system. This just shows you the export example one, which is property by property selection. So for example, from total materia, you can select properties and move those properties to a format which can be imported to any one of 23 different solver formats. Another example in one of our clients, specific clients' cases, is to be able to create a bulk export from the integrator module and deliver that to CATIA. In this case, it's not just about the material properties, it's about inserting maybe some additional information like rendering information, which would then be also included in the export folder and then exported to the repository on the company side, and then it can be imported into CATIA as a complete import file. And this is effectively what I've just described, but the whole point is to make sure that we have a comprehensive coverage of the information that's required on the material card. Another example might be to be able to have a slightly tight but light integration, let's say, and that means to call up access to the materials management solution from the software itself. This is an example of SolidWorks where we can simply click here, open up, make a basic simple material and properties selection, and then just bring that information through to the SolidWorks interface. So we're not even leaving the environment to make that decision. And so I want to put this together very quickly because this is effectively topping off the whole point of the connection of this system, and that's important. It starts with, in the case of the internals materials database, that's what you're looking to create. But you can't do that without substantial influence from an external materials source as well. So basically what we're talking about is creating an approved materials list, but pulling the foundation of those materials and those material properties from, in this case, the external source. So pulling the material properties, advanced properties like stress strain curves, fatigue data, any additional data, and bringing that in to combine with your own test data and diagrams that you have on your side. So in this process here, you have this organization and curation of data, and that's critically important to provide a single superset material for the end users. And that's done through validation and checking and making sure that it's good for release. Connecting that material to the outside world through connecting to international equivalencies or cross-references as we call them. Providing other information, compliance information about the internal materials that you have. How do we then exploit that data and communicate with other systems, PLM systems, ERP, other softwares? Exporting data I've already described and other potential softwares which can provide value. And this is combined with other information which is important to your business, whether it's about material pricing, transport, supply chain information. But the key point here is that everything is in one place and accessible by all of those roles that I've described in the first few slides of this presentation. A few seconds on future trends, because this is one of the things we said that we would talk about. Nothing, let's say, is a given, and it's a difficult topic to tackle without organized material, structured materials information in place. And that's really what I've been talking about in the last 20 minutes. Once you have the structure and the data in a place where it's validated, it's comprehensive, and you're satisfied that this is providing advantages to the business, that structure of information can be used in other ways. And there are different future trends appearing. Some of you may know the VDA specification, which is being developed or has been developed, which is about the control of information about materials. It's not just about properties, but also about other associated information, but it's about digitizing that content in a way to control and exchange information between different systems on the IT level. And that's important because as the VDA specification is developed, you understand the different parts of material information need to be included and standardized in a specific way. So if you have a relational database, it's possible to process this information and make it ready for this kind of technology. And this is important for up-and-coming technologies. We think about 4.0, Internet of Things. This is where we're going, but nothing is possible without enough data and without that data being structured. So VDA is something that's going to really help focus the conception from conception to production and form the basis of areas such as CAD, CAM activities, CAE and PDM. Really important in that context. And a couple of other interesting projects to mention which are also trying to standardize the approach, and this is more CAE focused, but there are a couple of projects running through VMAP, and the main focus of VMAP for the future is to have open interfaces for the exchange of material information in the CAE workflow. At the moment, as you know, there is no common language between different solvers, which means there's no compatibility. So VMAP is about creating an open source of materials information and information related to the CAE model, which will be able to be applied across all of the different softwares and vendors that are used. And there are different variations of the project, and now we're talking about, with them and Total Material Key to Metals are part of this VMAP group, talking about providing the data which will drive the discussion about integrating multi-scale models, sensor, data measurement, as well as information about production machines, open ontology for materials and related processes. And that's what we're focused on helping that project with. And it's because we can provide that data. All right, we're nearly there. I thank you all for your patience. Timing is not always the best on my side, but we're not too bad. We're a few minutes late. So let's think about the axis of the solution. So what's important about this? What does this mean, axis of solution? One of the statements we made in writing the material for the Industry Days website was that data management and handling materials information doesn't have to be difficult. It can be, but it doesn't have to be. And so the way in which we think about this and the approach that we take, it's about being able to utilize a source of comprehensive standardized data such as total materia to create the foundation of an approved material list, and then to combine internal materials data with that approved materials list that's been created inside the data management solution. So if we think about how long this can take, well, there's a few key steps. We have to validate, of course, the systems themselves. Think about the geographical application of this solution in a business. Is the data there at all? Is everything we need there? What about alternative materials? Do we need to check other solutions? That can take a couple of weeks to do some general, let's say, coverage and checking of the system. As you go to think about deployment of a material system, we start to think more in detail about approved materials. The objective, of course, is to have a single consistent materials language in the business. That means everything from material structure, thinking about how different groups within the business search for materials, what data those groups want to obtain, how do we just allow a simulation specialist to get hold of what he needs and quickly, and then export it to the software that he wants to use. How do we allow a materials expert to have a full view of the materials information to make, let's say, informed decisions about material specs, etc. So understanding that is critical in a deployment phase or in a consideration phase for deployment. And this is an organic process. So once a system is in place, it needs to be then, let's say, worked on. Users are key. Being able to scale and distribute this throughout the business for those different material roles, as I've discussed, is critically important. And that comes with time, but it comes with also understanding the usage behavior inside the business. The important thing is that it's scalable and possible to do. And as we move forward in this process, of course, the benefits and the value come to the business. So if I summarize what we consider forward-thinking materials management solutions, we have to consider different aspects. The architecture. Like I told you, having a fixed core data model or structure gives a possibility to do many, many different things with the data. Implementing or building a system is as much about implementation of data or inserting of data work, as it is about a nice, let's say, efficient user interface or GUI. Integration is critical, but to be able to integrate, the structure of the data needs to be accessible again. And the content is all important. The depth and the breadth of the content, providing for all areas of the business which require materials information. And can we make it our own? Customization. Are we able to take what is essentially a off-the-shelf material system and tweak or change to fit perfectly to our internal workflows and user groups? And of course, licensing, we can't avoid. Licensing is an important point. Is licensing scalable? Does it provide opportunity to roll out through the business? After all, this is about a business making the most of materials information and taking advantage of that, whether it's through better materials decisions or supporting the general business objectives of innovation. So this is about people being able to use the solution practically and provide value. And that is the end of the show. So I'm very, very happy that so many people came, and I wanted to just put this up just so you have a reference. I know that registering through the GoToMeeting or the GoToWebinar, you have my name and details anyway, so you should have my email address in the contact from GoToWebinar, but here it is again. If anybody would like to ask questions because we had such a short time today, please feel free to email us. We're happy to answer any questions on the general topics, on total materia, and also on integrator, which is our materials management solution. But everything that we talk about is incredibly important to us, so we're happy to discuss further with any of you here today. I think that's it then. So I again would like to just thank you once more for your attendance. I'm really happy that so many people came. Please keep your eyes for more from Key2 Metals AG in industry days, and we're going to be probably coming again to do more webinars and more topics. So we look forward to seeing you then. Till then, I wish everybody all the best. Please stay safe. And I look forward to seeing you in a future meeting. Thank you very much. Bye-bye.